So, guys, this is also FRQ1, right? I just wanted to show you that, this part right here. There's always gonna be two functions, right? It's not always gonna be a table, it could also be a graph, but for now, we'll just keep the tables, right? But I also wanted to show you this second part right here, the g of x, right? Don't panic. Don't panic if you don't see a polynomial or a rational polynomial, right? Here we have a log. But just like before, the previous video, right, where I was working out the whole thing, right? I only wanna focus on this one right here, right? Don't panic, like just treat it the same as we did for the first one, right? So, even when it comes to this end behavior, like the end behavior part, again, I don't know how this looks like, so put it on the calculator, graph it, right? So, just so you guys know what the heck is happening, x is supposed to be increasing, right? X is increasing, so the limit notation should be limit x approaching positive infinity, right? But I have no idea what this looks like, so literally if I wanted to, I could just go to the graph. So if I go to the graph and get out of this previous one that I did, right, and just go to graph, right, and I try to copy this one, so it's gonna be 3 log with the base of 5. So if I go over here, 3 with the log, where do I find the log? Well, you find the log right here when you have 10 to the power of x, so you just press control 10 to the power of x, right? The base was 5, and then my input is just x, right? Graph it, and there you go. So what's happening when x is approaching positive infinity? So when you start here, when x goes to positive infinity, what's happening to my y? My y is, well, it's increasing, so it should be g of x, I'm just gonna put it here, g of x is approaching positive infinity, okay? So that's just based on the graph. So you see how it doesn't matter what function they give me, you can just graph it because you're allowed to use a calculator here. So besides that, what else do they give me? Yeah, the same thing, right? Where else? Look at section C, right? In part C, this whole thing changed. Before we were looking for an inverse, but now we're looking for the model. It's a linear quadratic exponential, and we're focused on f. So this is where you have to find the difference. What's the difference between these, right? So 16 minus 8 is 8, 4 minus 4 is 8 minus 4 is 4, 2 minus 2, 4 minus 2 is 2, and this one's a 1, right? Are they constant? Is a rock constant? Well, no, just keep on going, right? Keep on going until they're all constant, right? So, besides that, what else? And C1, literally, the way you can answer it before, if it's inverse is yes or no, what's my answer? And this one, you can literally just answer, well, according to this, well, I know it's not linear, right? So I'm not gonna finish working it out, but I'm just gonna say, let's say it's quadratic, okay? And literally, all you can do is just put quadratic. All right, and then you can say, well, according to this, I do not want you guys to say a rock is constant. Alright, don't say that, please. You have to say, well, the rate of change, the average rate of change is being constant, right, during my second difference, right? Because literally, all we're getting these numbers, we're just subtracting them, right? During the second difference is quadratics. First difference is linear. Third difference is cubic, right, and so on, right? So again, the whole point of this video is don't panic if you see this, right? You can graph it, or you're allowed to use a calculator. Just know how to be able to find this little section, the log, okay? Or if it's ln, or if it's an exponential, okay?